We have reactions of monosaccharides, five important reactions of monosaccharides. We have oxidation to acidic sugars, reduction to sugar alcohols. Then we have also, we have phosphate ester formation, then amino sugar formation, glycoside formation. These reactions will be considered with respect to glucose. Other aldoses as well as ketoses undergo similar reactions. Okay, so let's focus here on glucose. But as well, other aldoses and other ketoses undergo similar reactions with this 5-1. Okay. So let's have first our oxidation reactions of monosaccharides. We have first oxidation. Okay, when we hear oxidation, okay, with an oxidation, it is an addition of our oxidizing agent. It could be weak and it could be strong oxidizing agents. Okay, so we have the oxidation gives three different types of acidic sugars depending on the type of oxidizing agent. Okay, so if we have here our glucose, this is our glucose, and if we use a weak oxidizing agent, so it's weak. Okay, oxidizing agent can, since it's only weak, example of it is Tollens and Benedict solutions. Okay, they oxidize the aldehydes. Okay, the aldehyde end to give an aldonic acid. So here it is. So this CHO, this is our aldehyde. This one. Okay. When it is oxidized using Tollens and Benedict's solution, then the CHO will become, the aldehyde will become a carboxylic acid. Okay, I'll give you more on that example. Wait. Okay, so the when we have our weak oxidizing agent, so if now let's go here. If we have our aldehyde, so we know that this is an aldehyde when we have, okay, double bind O, and then we have the H here, and then we have an R group here. Okay, so if we have an aldehyde using Tollens reagent, so it comes from a German chemist, so we have Tollens reagent, and then when we oxidize, we add an oxidizing agent. So sample, if we have this one as an oxidizing agent, so this will become a C double bond O, and then we have NOH. This one is our carboxylic acid. Okay, so we have our carboxylic acid. So we know that a carboxylic acid is formed from an oxidation of our aldehyde. So we have our carboxylic acid. So notice also, class, please know that an aldehyde came from also an oxidation of our alcohol. Okay, we have it here. Okay, so when we have our alcohol, okay, when we have our alcohol, which is C, and then we have an R group, and then we have an OH, and then we have an H. Okay. Okay, so that's it. If this one is has an, if we oxidize this one, Mm. This will form an aldehyde, which is C double bond O H and then R. So oxidation to an acidic sugar. So okay, so my point only is that an aldehyde, when we oxidize an aldehyde with uh, an oxidizing agent, it can be weak, it can be strong. So if it's strong, if it's under an acidic condition, this coin will form. Okay, if not, only carboxylate ion will form, negative, no H. So this is under a weak, okay. This is under not acidic condition. Well, this one is under acidic condition. So if we oxidize an aldehyde, then we can form a carboxylic acid. Now, in our lesson, we have our glucose. Glucose is an aldehyde, and when we use a weak oxidizing agent, so an aldehyde will be oxidized, forming carboxylic acid, which is COOH. We have this one, COOH. Aldehyde, CHO. Okay, so if we use a weak oxidizing agent, only the aldehyde group will be oxidized, forming carboxylic acid. While if we have a strong oxidizing agent, the aldehyde here will be oxidized, and then we have this one, carboxylic acid, whereas also the alcohol here will be oxidized also too because it's very strong. Okay, this is an alcohol, so it will be oxidized to carboxylic acid also. This one, since that there is an aldehyde, it the oxidation is from here only. But for this one here below, the oxidation is from primary alcohol to aldehyde, and then from aldehyde to carboxylic acid. So it's a two-step, okay, two-step oxidation reaction. Uh, it's possible because the oxidizing agent we are using is our strong oxidizing agent. Now, also we can, okay, we have also an oxidation wherein only the alcohol will be oxidized. This one here. Okay, so now let's name this one. When we have our glucose oxidized using a weak oxidizing agent, it will become carboxylic acid. So if the glucose will be then named as gluconic acid, because it came from uh, aldonic acid, okay, aldonic acid, and since it's a glucose, we will only, okay, we will use the onic, okay, onic part of the word, okay, because an aldehyde, when oxidized to carboxylic acid, it is now called as aldonic acid. But this one is a glucose. If we apply that one to glucose, this will become gluconic acid. Now, if we have an aldehyde using a strong oxidizing agent, it will become aldaric acid. Aldaric acid. Now, in this case, this is an aldaric acid. This is an aldaric acid, particularly glucaric acid, because it's glucose. Now, this one, when and okay, in biochemical systems, enzymes can oxidize the primary alcohol end of an aldose, such as glucose, without oxidation of aldehyde group to produce an aldoronic. Okay, as I've said earlier that an Okay, only the alcohol, okay, only the alcohol will be oxidized here. And we call that one as alduronic acid. Alduronic acid in this case, this is glucuronic acid. Okay, just like since this is glucose, now if we have galactose, when a galactose in an aldehyde group will be oxidized to carboxylic acid here, so it will become galactonic acid. Okay, galactonic acid. Now, what if we have a galactose when oxidized using a strong oxidizing reagent? Then we can call it what? We call it galactaric acid. Okay, aric. We use we use aric. Okay, galactaric acid. And then if we have a galactose, okay, in this case, if this is galactose oxidized, the alcohol will be oxidized. It will become galacturonic ac- acid. Galacturonic acid. Okay, so that's all it for our oxidation of monosaccharides. Then we also have reduction, the carbonyl group in monosaccharide, either an aldose or ketose. Class, we only tackle the monosaccharides and aldehydes in oxidation because usually using toluenes, uh, when you oxidize ketone, it's not possible. Okay, it's not possible. So here in oxidation, it's only for aldehydes. Then we have the carbonyl group in a monosaccharide, either an aldose or a ketose, is reduced to a hydroxyl group using hydrogen as the reducing agent. Okay, here last time in our oxidizing agent is our mostly our toluenes. Okay, toluenes and Benedict solution are oxidizing agent. Now, if we have in our reduction, when we say reduction, it is with reduction, gains of electrons. Oxidation, loss of electrons. Reduction, gain of electrons. This time we use our hydrogen as our reducing agent. In our in forming the in forming our glucuronic acid, we use enzyme as our reagent, as our oxidizing agent. This time let's use hydrogen as our reducing agent. Okay. So when we use a hydrogen here, the product will be an alcohol. Okay, so when we reduce an aldehyde, which means we gain electrons, and that electron is our hydrogen. So we have alcohol. Okay, so we call this one as glucitol. Glucitol, since this is glucose. Glucitol. Okay, and then it's glucitol or sorbitol used as moisturizing agents in foods and cosmetics and as sweetening agent in chewing gum. So the sugar there in your chewing gum is our glucitol. So it has an alcohol also. The glucose and then it has an alcohol glucitol. Okay, so that is our reduction. Okay, if you have an aldehyde, let's go back here. Okay, so if from aldehyde when forming an alcohol, the reaction is reduction. Okay. When from primary alcohol, from alcohol to aldehyde, that is oxidation. And then from aldehyde again to carboxylic acid, that's still an oxidation. So mostly we use Tollens reagent as our oxidizing agent, or we can use an oxygen, or oxidation is an addition of oxygen. Okay. And then we have reduction, and then let's go. Okay, so this time, okay, so that's it. We have the oxidation. Then let's go to phosphate ester formation. The hydroxyl groups of a monosaccharide can react with inorganic oxyacids. Okay, so the hydroxyl group. Okay, so wala sa na, di ba H man ni? Okay, H man ta na, but then, okay, we formed, ato na yung form dira. Okay, so the OH okay, of a monosaccharide can react with inorganic. Okay, inorganic. So this one, oxyacids. This is inorganic. Inorganic means it has no carbon. No carbon. So inorganic esters, okay, forming oxyacids. Alright, now wait a minute. Okay, so we have our carbohydrates, our glucose. When it reacts to our phosphoric acid, this one. Okay, when it reacts to phosphoric acid, it attacks the OH in our anomeric carbon. So it's in carbon 1. Because we have phosphoric acid as this one. P double bond O, OH, OH, and then we have OH here. So the OH here will attack the OH here in our glucose, thereby forming this one. Okay, and then another also product is that would be water. Okay, so we have that one. So that's why we have this one. And when we call this one as, since this is D, so we have, and the OH, okay, the O is down, so we call it as an alpha. Alpha D glucose, D. And then, okay, D glucose. Then we put the phosphate. Since the locant is 1, it's in carbon 1, so we write 1 and then phosphate. So that's it. Unlike to this one, this second structure is our alpha, since OH here below. And then we have the phosphate ion. The phosphate ion reacts with our CH2OH, or in our carbon 6. So we put alpha D glucose and then we put 6. That's the locant of that's the position of our phosphate ion. So it's in carbon 6, so we call that one alpha D glucose dash 6 dash phosphate. So in organic chemistry, you know this type of naming. Oh, aside from that also, class, because our phosphate, why our phosphate reacts with our glucose? Because our phosphate, it's an ion. So when it's an ion, it has negative. Okay, it has negative. Okay, when it's negative, it's very reactive, and that's why it reacts here. So it reacts to our glucose, forming 1. Okay, this one is 1 molecule and our glucose is 1 molecule. But it happened that our phosphate ion is very unstable. It's very reactive because it's negative, and then it tries to attack the carbon 1. It tries to attack carbon 1, and then carbon 1, since carbon 1 is ano po siya, hina, so the phosphate ion was able to beat, and then the OH was napalayo, forming the OH here, napalayo man ni siya. Okay, napalayo to, but then thereby this one, a combination, so we have the glucose and then we have the phosphate. That's it. So it's 1 here because the phosphate ion is in our carbon 1. It's 6 here. The name in the second structure is alpha D glucose number 6 because the phosphate is in D carbon, or is in carbon 6, sorry. Okay, so that's the locant, that's the position of our phosphate. Okay, so phosphate esters, we call this as ester because we know in organic chemistry that an ester is, we have R, and then we have O, and then we have R again. Okay, so we have phosphate ester of various monosaccharides. Okay, so the R here, okay, if this is our oxygen, the R1, okay, R1, this will be our R1, the rest here, the glucose. Glucose is our R1, and then R2 is this one, the phosphate. Okay, so that's why we call it as phosphate esters. Okay, so if of various monosaccharides, so various, it could be galactose, alpha D galactose, 1 phosphate, fructose, phosphate, that one. Here, it's only glucose, so mag-representation na siya for monosaccharides. Okay, mostly we will be sa monosaccharide kay ito ginagamit is ang glucose. Because aside from kay glucose is most abundant man siya and very sa to our body, and aside from that, all monosaccharides, all disaccharides, oligosaccharides, and polysaccharides will be converted to glucose. So that's why. Okay, so they are very stable na siya. They are stable, and they play important roles in our metabolism. Okay, so metabolism of carbohydrates. This is another chapter. Okay, now let's go. Then metabolism of carbohydrates is the process of using our carbohydrates in our body. Okay, so we have also the reaction. We have the fourth, I think. Okay, reaction. We have amino sugar formation. Okay, so when we have, this one is a phosphate ester formation. It is the formation of phosphate here in our glucose. This one is reduction, and then we have oxidation, the formation of acids, carboxylic acids. This time, the formation of amino sugar. When we say amino, it has nitrogen. Okay, it has nitrogen. We have N. Okay. So one of the hydroxyl groups of monosaccharides is replaced with amino group. Okay, so one of the hydroxyl groups. So we have OH, the OH, the OH. And then even here, it's OH in glucose or monosaccharide. But because our monosaccharides has reactions, okay, it can become, one of it is the amino sugar formation. So the OH will be replaced with our amino group. Amino group, any molecule that has a nitrogen, that's an amino. Okay, this one also here, we call this as glucosamine. Okay, glucosamine. Wait a minute, ha. I can see it clearly. Wait. Yes, glucosamine, because this is a glucose. And then NH2, it's our amino, so we call it amine na lang, amine. Glucosamine, and then this one is our, okay, this is our galactose. So galactosamine, and then the third one is mannose. This one is our hexose mannose. Hello mannose, it's where usara kay kana mo encounter, but we call this one as alpha manosamine. Alpha because of the OH. OH is below the ring. Okay, and this is mannose. Okay, mannose. And then we have this one. Okay. Oh, that one. This group is just replaced with amino. This group also, amino sugars and their N-acetyl derivatives are important building blocks of polysaccharides such as chitin and hyaluronic acid. Okay, so this one is an N-acetyl. N-acetyl. Okay, NH2 is amino. And this one, NHC2H3O, that is acetyl, N-acetyl. Okay, when N-acetyl is connected, is attached to our our monosaccharide, we call that one as N-acetyl. Okay, padako man di ay siya. Okay, we have it here. N-acetyl, that's the name here. And then alpha-D-glucosamine. Okay, so we still use amine. Okay, alpha-glucosamine. Okay, I see. Because class, this is glucosamine. This one is glucosamine. It's this one. This one. Mama ni siya, no? And then we have N-acetyl. Okay, this one is our acetyl. C double bond O, CH3, and then we have R. This is our acetyl. But because it is N because here, the R group is our N. It's N. It's N. Okay, so that's why we call it N-acetyl alpha-D-glucosamine. Okay, class, you take note also of the naming. Okay, naming is very important also, but it's okay, class. Kaya rin ninyo na. Actually, class, this good. It's on inorganic chemistry, but wala pa mo, since wala pa mo nakatako, but it's okay, it's manageable, you will learn this one, and you can learn, Jude, because I believe in you. Yeah, yes. And then we have this one. What monosaccharide is this? This is galactose, because this one is a glucose. And the OH, the only difference is the C4. The C4. We have carbon 1, carbon 2, carbon 3, carbon 4. Okay, only C4. So this is a C4 isomer of our glucose. So this is our galactose. And then this one, the whole thing, because it's connected with an amino, it is attached with an amino. So this whole thing is our galactosamine. And then we have our acetyl group here. So we call that one as acetyl. But let's not forget that the acetyl is connected to our nitrogen. So we call it N-acetyl alpha because of the OH lying below our ring. And then we have D galactosamine. Okay, it's D because the CH2OH is appears above the ring. Okay, when it's below, then CH2OH, then that would be an L group. Okay, L enantiomer. Okay, class, so you can do it. I'm shouting because it's raining. Uh, please bear with me. Okay, because I don't have to, di na kumundang. Ano na siya, dapat mahuman ako ni Ron. Okay, and then we have the glycoside formation. We have the reactions of monosaccharide. Okay, again, so this is the fifth, I think. So glycoside formation. Okay, so what is glycoside? Now let's read first the cyclic forms of monosaccharides and then the hemiacetals. Okay, so the hemiacetals. Alright, the hemiacetals class. This one, beto. The C1. Okay, the hemiacetals react with alcohols to form acetals. Okay, so you have your hemiacetal. It's in C1. Okay, hemiacetal. This one is your hemiacetal. Then it reacts with an alcohol to form acetals. I see. Balik-balik at class. So formaldehyde, we've, ano naman to, diba, here? Okay, wait a minute. Okay. Alright, so we have, okay, diba, an aldehyde, when an alcohol attacks an aldehyde, you can form hemiacetal. But this time, when a hemiacetal, again, is attacked with an ROH, or R2, okay, an alcohol, then you will form acetal. Okay. Okay, an acetal. So, an acetal class. So, we have the OR here. Okay, the OR. So, it will attack the carbon here. And then, okay, so the OH will be replaced. Okay, the OH will move. And then it will be replaced with OR. So forming, we have that one here. I'll write it here, ha. I hope that you can follow. Okay. We have OR, 2, then we have H. You see this one? This is an OH first, but then when it is attacked with an alcohol, it becomes an OR. Okay, so this is our acetal. Our acetal. Now, what if we have, i-discuss na lang po dako, wait. Okay, so this is our acetal. Okay, alright, sorry. Now, what if we have, ano ba siya? Okay, what if we have our kettle? If a hemiketal, when it is attacked with an R2OH, okay, so the OH here also will be replaced with our OR. Okay, forming, we have COR, and then R3, we have R1, we have OR2. Okay, so that's it. When a hemiacetal or a hemiketal attacked by an alcohol, the OH will be replaced with OR. Okay? Alright. And that acetal is also called as our glycosides. Okay, so this one class, we have it here in our hemiacetal, in our anomeric carbon. This is our hemiacetal. It's OH first, and then it was reacted with an alcohol. This alcohol is our methanol. Okay, it reacts with a methanol. So the OH, okay, it's an alcohol because of OH. And then now it will be replaced, the OCH3 will mupuli siya sa OH here, forming this one. You see this one? Okay, that one. Yes. Okay, this one. So this one is our glycoside. Okay? So our glycoside. No, dili pud tanan glycoside. Wait sa class. This one. Okay. This one is our glycoside. Glycoside. And then we have the CH3. It's methyl. So we name this one as methyl beta. Beta because it's beta anomeric. Naman siya sa taas, no? D, kay D, glucoside. Beta, methyl beta D glucoside. Glucoside. Okay, kay kaniman ang ato ang glycoside. Glycoside mo na to ni siya. Glycoside, and it happened that this is glucose, so we name this one as glucoside. But if this is a galactose, we will name this one ang OH mabot dire, then only H here. This is a galactoside. Okay, methyl beta D galactoside, but it happened this one is glucose. So a glycoside is an acetal formed from a cyclic monosaccharide by replacement of the hemiacetal carbon OH. Mao di siya to hemiacetal class ha. Hemiacetal carbon or anomeric carbon. Ang OH may mo siyang OR with an OR group class. Ang OR bitaw class, ang R bitaw ana. R is just a representation. But usually it is an alkyl group. We have CH3, so it's methyl, we have ethyl, propyl, butyl, mono. And then we have a glycoside produced from a glucose form glucoside. Okay, if we have a glycoside and it is a glucose, we call it glucoside. If the monosaccharide is galactose, we call it galactoside. If it's fructose, it's fructoside. Okay. Alright. Naman din ni diri. Mahope makita ninyo. Alright. Okay, we have here alpha D-glucopyranose. Okay, so this is our glucose. And then it reacts with a methyl alcohol. And then, okay. So the OH will be replaced with our OR. Meron sa OCH3. We have our glucoside. Now, class, the bond. Okay, the bond here, class, the line. That is a glycosidic bond. Glycosidic bond or glycosidic bond. So, it is a bond that links our glucose and our alcohol. Okay, so that is our glycosidic bond. It's a link that forms glycoside. Okay, so maka-form na siya glycoside. So that is the glycosidic bond. Ang bond. Okay. Alright, so we have here okay. We have the monosaccharides, derivatives. And then we have acidic sugars, okay, obtained from oxidation. So, oxidation, katong aldonic, may mong alduronic, and then we have aldaric acid. And then we have sugars, okay, obtained from reduction. Okay, ang reduction is the addition of hydrogen. And then may mo siya alcohol, so may mo siya alditol. And in this case, this is glucose, so this is glositol. And if it's galactose, galactol, galactose. Yes. And then we have this one. The glycosides, okay, is a reaction with an alcohol. Remember this one, class? Glycoside is a reaction when a hemiacetal reacts with an alcohol. So that forms a glycosides, and the bond that links them is a glycosidic bonds. Sorry. Alright, and then we have the phosphate esters. Okay, another reaction of our monosaccharide. A phosphate ester when a phosphate ion reacts with our glucose or our monosaccharide. Okay, you remember the naming, class? We have, in this case, this is alpha D glucose 6 phosphate. Okay, alpha D glucose 6 phosphate. And then we have also the reaction of our amino. Okay, we have amino sugars, and then we have the amino sugars is OH is replaced by an amino group. This one, NH2 example. So we call this one as alpha D glucose, still glucosamine. Okay, alpha D glucosamine. But also remember, you take note also of the N-acetyl group. Yes, you also take note of that. Wala lang siya dire. And then we have D-glucose. It's an aldohexose. It's most abundant monosaccharide, and it is often called as blood sugar. And then we have D-galactose. D-galactose is a C epimer of our glucose. It looks like the same to glucose, just that the carbon 4 is the OH, the position of OH or hydroxyl group is not on the same of our glucose. Okay, it's a different structure from glucose. Okay, we have carbon 4. Alright, the galactose is also often called as brain sugar. And then we have the D-fructose. It's a ketohexose. It's a ketone. Now, ketone class, in a ketone does not participate in an oxidation reaction. Okay, only the aldehydes. And then we have structurally identified to glucose, a carbon 3 to carbon 6. Oh, okay, so take note of that. In carbon 3 and carbon 6, it's different now. And then we have the fruit sugar. Fructose is a fruit sugar. It's very sweet. And then we have D-ribose. It's an aldopentose. It's an aldehyde that has 5 carbons. And its structure is that of glucose with carbon C. Carbon 3 is removed. Okay. Now, class, this is ano siya. It gives you a hint of identifying monosaccharides. Okay, then important in nucleic acid chemistry. Okay, that's it. So, yay! That's all for monosaccharides, class. Now take note of the reactions. Okay, the reactions, the names. Okay, yes. And then now, next video, we will tackle about the disaccharides. Thank you.